Alright, so in this equation, I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So, to solve this equation, I'm obviously solving for the variable x. And for my solution, I'm going to first start by rewriting my equation down here so I have more space. So I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. And I'm going to first start by rewriting all my terms in powers of 3. So my numerator over here, this is already in a power of 3, so we don't have to change that. Now 9 to the power of x, I can rewrite as 3 squared to the power of x. And 81 I can rewrite as 3 to the power of 4. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2 times x, which is just 3 to the power of 2x. And this is equal to 3 to the power of 4. Now from here, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of x to the power of 3 minus 2x, this is the result, and this is equal to 3 to the power of 4. Now from here, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x to the power of 3 minus 2x is equal to 4, and x to the power of 3 minus 2x minus 4 is equal to 0. Now to solve this equation, because this is in a quadratic equation, what I actually have to do is find one solution and use that one solution to find the rest. So I have to find that one solution by testing. So I'm going to first test out x is equal to 1. So if x equals 1, I get 1 to the power of 3 minus 2 times 1 minus 4, which does not equal 0. Now if x is equal to 2, I get 2 to the power of 3 minus 2 times 2 minus 4. 2 to the power of 3 is 8, 8 minus 4 is 4, and 4 minus 4 is 0. So this does equal 0, meaning x equals 2 is a solution, and x to the power of 3 minus 2x minus 4 over x equals 2, this actually has a quotient. So to solve this, what we're going to have to do is use synthetic division. So if you guys don't know what synthetic division is, I would recommend going to watch a video on it. But for synthetic division, 2 is going to be what we're going to put outside of the box because x is 2. And now we're going to use our coefficient. So our first coefficient is 1 because that's the coefficient in front of x to the power of 3. Now we don't have an x squared, so we just put a 0. Our next coefficient is negative 2, and our last coefficient is negative 4. Now I'm going to drop the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 2 plus 4 is negative 2. And 2 times negative 2 is negative 4. Sorry, it looks like I've made a mistake. Negative 2 plus 4 is positive 2. 2 times 2 is 4. Negative 4 plus 4 is 0. So I have a remainder of 0, and I get x squared plus 2x plus 2. So this means that x squared plus 2x plus 2 times x minus 2 is equal to x to the power of 3 minus 2x minus 4. But remember, x to the power of 3 minus 2x minus 4 is also equal to 0, meaning this is equal to 0. And now I can divide this into two equations. X squared plus 2x plus 2 is equal to 0, and x minus 2 is equal to 0. So for x minus 2 equals 0, I get x is equal to 2. And for x squared plus 2x plus 2 equals 0, I can use the quadratic formula. So I get negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 2, and c is 2. So I get negative 2 plus or minus the square root of 4 minus 4 times a, which is 1, times c, which is 2, all over 2a. So 2 times 1. And this is equal to negative 2 plus or minus the square root of 4 minus 8 over 2, which is equal to negative 2 plus or minus the square root of negative 4 over 2, which is equal to negative 2 plus or minus the square root of 4 times the square root of negative 1 over 2, which is equal to negative 2 plus or minus 2i over 2, which is equal to negative 1 plus or minus I. So I get x equals 2 and x is equal to negative 1